To learn more about earning college credits with study hall courses, visit gostudyhall.com or click the link in the description. Most of the time we interact with computers, we're not working with pure code. When we open internet browsers, PDFs, or desktop folders full of pictures of my cat because I have to have them ready at all times for sharing, we're clicking through a user interface that's designed for the average person, who probably isn't an expert in Java. Our goal as programmers isn't just to produce code that runs, but also to present results in a way that's accessible to all kinds of users. If you stick your data in a Java array list, that's great, but it doesn't help the CEO who barely knows how to open a PDF understand what you're working on. Luckily, we can take our code results outside the Java compiler and transform them into something less technical. Whether it's a document, a spreadsheet, or a plain text file, Java provides some powerful tools to transform data into more accessible formats. Hi, I'm Sabrina Cruz, and this is Study Hall, Code and Programming for Beginners. One way to make our code more accessible and user-friendly comes back to storage. Computer programs can only store things temporarily. When a program stops running, the data stored in computer memory by that program gets lost. Same deal if it's interrupted by a random shutdown or a glitch in the matrix. When a program is running, any data required by that code is stored in RAM, which stands for Random Access Memory. RAM can quickly change its contents, which makes it really convenient when we're coding or debugging in real time. But there's a trade-off for that flexibility. RAM requires constant power, and shutting down the computer shuts down the RAM. When that happens, any data in the RAM is effectively gone forever. It's sleeping with the fishes, is what I believe the technical term is. In some cases, that might be fine. A lot of the coding exercises in this series, for example, don't require data backup. We don't need to save and access our random collections of numbers, strings, or radioactive mice outside of a Java compiler. But we can make the choice to rescue our data in distress and carry it from the short-term RAM to the drive, our computer's long-term memory storage that works even after the computer shuts down. This idea of persistence, or data that persists outside of a specific program because it's been transferred somewhere else, is actually a technical term in computer science. Persistence is basically like writing information down for your future self. Whether it's a grocery list, a dream, or a video idea, you might not remember the train of thought that led to what if you filled a hockey rink with Jell-O instead of ice. But the idea persists in a concrete form in case you need it later. I'm just gonna write that one down though. Just like we can capture fleeting ideas with handwritten notes, we can save digital data from our computer programs with files. This process of moving data from short-term RAM into long-term drive storage is called writing a new file. It also makes it easier for other people to use our code later. And what do you know, there's a very dedicated and very fictional programming teacher who needs to do just that. Meet Kai, one of those cool teachers who want you to call them by their first name. They're creating a list of their top 10 programming students, otherwise known as the coolest kids in school, because they're going to win their school's Coding Wizard Award. Sure, Kai could just write 10 names on a sticky note, but where's the fun in that? Instead, they're going to write that data to a file using Java. There are a lot of different steps to writing even a simple file like this one, so let's break it down. First of all, Kai needs to import some tools. They'll use Java's I/O package a lot here to handle inputs and outputs. That's what the I and O stand for. Specifically, the three tools that they need are the FileInputStream, the PrintWriter, and the I/O exception. FileInputStream is basically a pipeline that allows you to send data from your Java program to a file. One of the file types supported by FileInputStream is a CSV, or comma-separated values file, which is exactly what it sounds like. You might have seen the file extension .csv before if you've worked with data stored in tables or spreadsheets and that very annoying possible data loss warning in Excel. But there's a catch. FileInputStream is good at writing data at the byte level, which is kind of like a raw stream of data, and our student name data is text, not bytes. That's where the PrintWriter comes in. It converts text into bytes so that the FileInputStream can work with the data more easily. In other words, the PrintWriter carries data into byte form to the FileInputStream, which is actually responsible for moving the information from RAM to long-term storage. So, Kai will drop their student names into a user-friendly CSV file using the PrintWriter. That is, if everything goes well. They need to be ready in case they run into a problem. For example, if they don't have the file permissions or the file type is wrong. If that happens, Java will throw an I/O exception, and since they know what type of error they might run into, they can plan ahead and catch the I/O exception before it happens. Now that Kai has imported their tools and has a plan, they're ready to start coding the main function. The first thing they need is a string array of the student names separated by commas. That's the data that they'll be writing to the CSV file. Next, they want to make sure that they avoid a potential compiler error. They can't write any files if the code doesn't work. So, Kai initializes a PrintWriter variable to null. This way, if something goes wrong, the PrintWriter object will at least be defined and the whole operation won't just crash. And that brings us to the next section of code, which is called a try-catch block. In this block, Kai will try to set up the PrintWriter by supplying it with a file output stream and a file name. If students_names.csv already exists, they'll overwrite the file, and if the file doesn't exist, they'll create a new one. Then, if any problems arise, Java will catch the exception, which we call E, and print out the stack trace so that they can find it and debug. Now that the PrintWriter object is all set up, Kai is ready to start printing data from the program to the file. Because CSV files are formatted as tables, they start by adding a column header. Without a header, anyone reading this file just wouldn't know what data they're looking at. It's just a good habit to add labels. To add the header text student names, they use the printLine method. And Kai uses the same printLine method to set up a for loop that prints each name in the list. Once all the data is moved into the CSV, Kai closes the PrintWriter object. This will make sure that the information is stored safely to the correct place, and it frees up the computer's resources for other jobs. Now, it turns out that the student with the best average on their exams also receives the Very Good at Taking Tests award. Kai really loves giving out awards. Some people would just do some quick math on a calculator here, but a diligent programmer like Kai wants to calculate these average scores in Java. Also, because we need them to be a good fictional example. In this case, they have a text file of student names and their test scores. So to get those into a Java program, they'll need to read a file. Like the name suggests, this is the opposite process from writing a file. We're moving or copying data from long-term drive storage back into short-term RAM variables that we can access in code. To read a file, Kai needs to import a couple more tools. We have our old friends, the scanner and the array list. But we also have the FileInputStream, which interprets any file 1 byte at a time. To kick off the main function, Kai sets up another try-catch block, and the first thing they do within this block is create a FileInputStream object to read the text file. And instead of reading it 1 byte at a time, they build a scanner. This way they can use the next line method to move through the data more quickly. They also need a place to store all this data in their code, so they create an array list of strings for the names. And here comes the fun part. Because each student has 3 scores, each element of the scores array list has to contain several elements, which means a list of lists. They just make me happy. Each element in the names array list corresponds to an element in the scores array list, so names and scores are considered parallel arrays. They're related in a way that's important for the task at hand and work together to produce a result. Now that all of this data has a place to go, Kai can while loop through the file to read it all, and once all this information is safely moved into the RAM, they can start working with it. Remember, the reason that they're doing all of this file reading is to calculate the average exam score for each student and crown a very good test taker trophy winner. So they'll need to start this part of the program by creating another array list called averages to store the calculation results. Now it's time to iterate through the scores array list. Kai uses a nested loop to add up each student's scores. Because remember, each element is itself an array list of 3 test scores. Next, they can calculate the average by using simple math, dividing each student's sum by the length of the student's scores array. Then they store the results in the averages array list. Now Kai is ready to write all of this information to a new CSV file called student_averages.csv using everything we learned earlier. After writing the header, they loop through the names and averages arrays, concatenate relevant lines together, and print those to the file. Finally, it's time to close the PrintWriter, FileInputStream, and scanner, which means we're done with the very, very long try block. The catch block does the error handling, and that's it! It looks like Elijah Patel will be named the Very Good Test Taker of the Year with a stellar average of 96%. Great job, Elijah! In this series, we've learned a lot of different ways to communicate with computers, and each of them has a time and place. Collecting information from the user through the keyboard is great for small interactive programs, but it's slow and pretty limited. And printing a program's output to the console is awesome for debugging code or building out our backend, but it's not very user-friendly. But our computers are literate in the sense that they can read and write files, and it's up to us to leverage that power and transfer data seamlessly into and out of our programs. Good programmers get work done, but the best programmers package their work and outputs that are easily accessible to other programmers with other software or non-programmer collaborators. Because whatever we're working on, we actually create effective programs and solutions as a team. If you're enjoying Study Hall Code and Programming for Beginners and are interested in taking an online course and earning college credit, check out GoStudyHall.com or click on the button to learn more. Thank you for watching, and see you next time.